of calculus. Here we go. I had to put a lot of words in here because that's fun. So the first part of the fundamental theorem has to do with these integrals that we've been doing. Okay, but you'll notice there's one major difference. This is talking about on interval a to b, but my upper limit is x. It's still a variable in here, and we haven't had that. We've only had numbers for our limits. Okay, so we know that if these limits are two numbers, we get a number answer, right? We do the antiderivative, we plug in those numbers, we subtract them, we get a nice number answer. But if x stays in variable form, then we're not really getting a single number for an answer because you're plugging in an x, so you're talking about some kind of expression. Essentially what that's telling us is you could think of it as calculating the area up to a certain point. You know, starting at A and then ending at X, you could basically be finding a formula for what that area might be at any given point in time. Or it's like the area so far up into this point, what would be the area under the curve? So first, we're going to talk about like a graphical example before we actually start dealing with the equations themselves. So here's a function, and g is the integral from 0 to x. In other words, it's saying the area under this curve from 0 up into whatever point that we might plug in. So if I ask for g of 0, that's saying the area from 0 to 0. What would that be? 0. We didn't go anywhere. Okay, so g of 1 is saying the area from 0 up to 1. Okay, so if I try to approximate those, what do you think that would be? Yeah, each of these squares has an area of 1. You know, if you took this part and moved it down, it's about 1 whole square that's shaded. So g of 2. We already know this part is 1, and then we're adding in this. So what would our area be at this point? 3. Okay. G of 3. So we have an area of 3, and then we have to add in that. What do you think that would be?
2.75.
What? It's more than 1. We were at 3 so far.
Maybe
So it's 4 and a little more. You think like 4.3? Adding in 1 1/3 boxes. What happens at 4? Yeah. So my area we'll have to subtract off. Now isn't that about the same as this one right here? So if I subtract off that 1.3, then we would be back to a total area of 3. If I added in 5, so we're subtracting off again.
Distance it looks.
Yeah, about the same. So if I subtract 1.3 again, so 1.7. All right, so then if I asked you to graph G, what you essentially have are all these ordered pairs for points on the graph of G. So, plot. So we had 0, 0, 1, 1, 2, 3. 3 was 4, and 5. So then if we calculate, we just drew a rough sketch of a graph, G might look something like this. Is that a perfect graph? Absolutely not. But we use those values to estimate it. So far, so good? Alright, so the fundamental theorem of calculus, part 1, tells us if you have a continuous function defined on a closed interval from a to b, where g is the antiderivative from a number up to some variable x, then the derivative of this, so a derivative and an integral cancel each other out, right, is just f of x. Okay, that seems kind of confusing, but let's just do an informal example So if I said like g of x equals integral from 0 to x of 2t minus 1 dt. Okay. If I ask you to integrate this, what is the antiderivative of 2t minus 1? T squared minus t from 0 to x. Okay, so if you plug in your x's, you get x squared minus x minus, if you plug in 0, you just get 0. 0 may not have been the best choice. But if I ask you to then do the derivative of it, the derivative of x squared, 2x minus derivative of x is 1. And even if this hadn't been a 0, it's a number. What's the derivative of any number? 0. So it would go away no matter what. So if I asked you to do the derivative of this integral, all it did is cancel the integral, but my variable became x. Okay, that's all that really changed there. So let's do a similar example. I want to do it two ways. I'll work it out, and I'll do the fundamental theorem of calculus. So the fundamental theorem of calculus says if you want the derivative of an integral, they just cancel each other. But what will all these t's become? So it becomes x squared plus 2x plus 1. And that's it, because a derivative and an integral are opposites. Okay? This was a continuous function. It's differentiable because it was an x polynomial, so the fundamental theorem works. If you actually worked it out, first you would have to do this integral. So what is the antiderivative of t squared plus 2t plus 1? 3 to x. Okay, if I plug in my x's, minus, if you put in a 3 cubed is 27 times the third is 9. 3 squared is 9. And we get this for the antiderivative. And then what do we have to do? I wanted the derivative, so we did the integral, and then if we did the derivative, what do you get? Minus 0, so we just get this. So same answer two ways, just fundamental theorem of calculus required 0 work, because we know the relationship between an integral and a derivative. Alright, so let's do some. In order for the fundamental theorem to work, it has to be continuous and differentiable. Keep in mind, this is a square root. It's defined as long as what's underneath is positive. 1 plus t squared would always be positive, right? So we could do this. So if I want the derivative of it, can you guys just tell me what it is? Square root of 1 plus x squared. And that's it. That's the fundamental theorem of calculus. Okay, now I want to see what happens if I don't have just an x here, if I put something else. So we are going to first work out a problem and see what changes, and then see if we can figure out what a shortcut might be. So if I asked you to find the derivative of this integral, first we have to do the antiderivative. So the antiderivative of 2t, minus antiderivative of 3. Okay. So I'm evaluating that from 1 to x to the 4th. So if I plug that in, you get x to the 4th squared minus 3x to the 4th minus, if I put in a 1, so we get x to the 8th minus 3x to the 4th plus 2. Now I want the derivative. So derivative of x to the 8th minus derivative of 3x to the 4th plus derivative of 2, 0, so I don't need that. All right, so can you figure out how is this related to that? It's not real obvious, is it? If you take that out.
Multiply it.
Okay, does that look closer? So we had an x to the 4th here, and you notice my t got changed to an x to the 4th. Where do you think the 4x cubed came from? Derivative of x to the 4th. It's like a chain rule. So we can do the shortcut on this as well. You just replace your variable with whatever that limit is and multiply by the derivative of it. All right, so if I ask you to do this one, d over dx, that just means the derivative of secant t dt. So what would I do? Chain rule, so this would become the secant of, and what would I have to multiply everything by? So it's that times the 4x cubed, or you could just put the 4x cubed in front. All right, are we okay with the first part of the fundamental theorem? So now let's look at the second part. This is what we have been doing already. So we didn't call it the fundamental theorem, but it's what we did. We did the antiderivative. So an integral just means the antiderivative of the upper limit minus the antiderivative of the lower limit. So it's nothing new at all. So those two pieces together are your fundamental theorem of calculus. So let's just continue. These integrals aren't going away, so even though we've already taken the test, we're just going to be building off of them, so we're still practicing. What is the antiderivative of e to the x? And we are integrating from 1 to 3, so we get
E to the 3rd minus E to the 4th.
and that's our answer. With area under the parabola y equals x squared from 0 to 1. What should we do? Area under a curve means the antiderivative from 0 to 1. X squared, what do you put on the end of this? Antiderivative of x squared?
1/3 x cubed.
0 to 1. So you can keep the 1/3 with it, or you can pull the 1/3 out and just do 1 cubed minus 0 cubed. here. Mhm. You could think of this as a 1 over x dx or an x to the negative 1 dx, either way. So the antiderivative of x to the negative 1 or 1 over x is the natural log of x. You get the natural log of 6. That's the natural log of 3. Okay, bonus question. Does anybody remember how to combine those? How do you condense logs? If logs are subtracted, we divide the arguments. This becomes the natural log.
When did we learn that?
College algebra.
Oh, I didn't do that.
2 years ago.
Pre-calculus algebra, we did that there too. When we talked about logs at the, probably about right now, because my pre-calculus algebra class is doing
Yeah.
now. Well,
So probably where Miss Circled was not here.
oh my goodness, are you gonna hold that over my head forever?
Out because she had.
Decided to have a baby.
Decided.
You guys are so bitter about that.
It was a decision.
Let's look at this one.
Oh, great, that's the back.
Absolute values, yes. What do?
Split it up.
Yep, we have to split it up, and to figure out where to split it up, we have to know what makes it equal 0, right? So I need to know what would make x cubed minus x equal 0. So what would you do?
What an X.
So what makes this 0? 1, -1, and 0, right? So we're going to go from -1 to 0. And then we'll have to go from 0 to 1. And then we'll have to go from 1 to 2. Alright, if you plug in something between -1 and 0, is this positive or negative? So think about, like, if you put in a -1/2, then you get -1/8 minus -1/2.
Positive.
That's a positive, so the absolute value doesn't change it. Alright, if you put in something between 0 and 1, so if you put in a positive 1/2, then you get 1/8 minus 1/2. Is that positive or negative? Negative, so the absolute value does the opposite. Could I just write it as x minus x cubed? You guys, or let me do this. -x cubed plus x. I'll just distribute the negative. If we put in something from 1 to 2, even if we put in a 2, we get 8 minus 2, which is positive. So the absolute value does not change it. So now, start working it out. Antiderivative of x cubed minus antiderivative of x. Okay, and we're doing that from -1 to 0. Right, -x cubed would be -1/4 x to the 4th plus x, so that's 1/2 x squared. 0 to 1. Work these out. So if I put in a 0, get 0 minus, if I put in -1, So I want h prime of x. So what do? Okay, you can plug in that x squared for the t, so it's x squared cubed sine of x squared. But then we have to do the chain rule because that wasn't just a plain x, so derivative of x squared. So that's an x to the 6 times 2x, so you get 2x to the 7 sine of x squared.
Oh, is it?
That's it.
Oh, okay, you got it.
Let's stop here for today. Homework. You've got a lot of time right now to start. So 2, 3, 7 through 17 odd, 19 through 39 every other odd, and 53. This will be due Wednesday. Tomorrow we'll finish this section.
I will